Some key things to keep in mind about vitamins is that they're going to be organic. And think in your mind, are they energy yielding or non-energy yielding? Right, we're not actually going to get calories from them, so they're non-energy yielding, right? The energy yielding ones are going to be our fats, our carbs, and our proteins. However, we are going to see that vitamins are going to underlie all metabolic processes. So we're not going to get very far with digestion, with metabolism, without our vitamins. So even though we're not technically getting calories from them, we need them to get calories from our food. So the origin of the word vitamin, so vital to life, is really, they're critical to life, and that's very much the case. A lot of our vitamins were discovered serendipitously. These are just kind of two extreme clinical conditions that can result from a vitamin deficiency, so spina bifida. So this is a neural tube defect. A lot of you may be really aware of the importance of taking folic acid when you're pregnant. These spinal deficiencies can actually develop before a lot of women realize they're pregnant. So that folic acid, one of our B vitamins, is really, really critical to a lot of early developmental processes. Most children with neural tube defects don't make it, so it's really, really critical. And then here's a kiddo who had rickets. So rickets is a vitamin D deficiency. We'll see that vitamin D, if you're not already aware, has a big impact on calcium and bone strength, calcium absorption. So in these children, they often present with bowed legs. Now this is 2 months after treatment in this little guy. So they can definitely come back from this depending on how young they are when they're diagnosed, and also how bad the deficiency was. So in a broad overview of vitamins, they're going to be different from energy yielding macronutrients. So with regard to the structure, we've talked about how proteins are large units of amino acids that are assembled together. We've looked at how fats are these triglycerides, right? So glucose with fatty acid tails coming off of them. And also with carbohydrates, right? We have these monosaccharides, and we could string monosaccharides together to make a polysaccharide. So in all of those cases, you have these smaller functional units that make up a larger macromolecule. That's not the case with these vitamins, right? Their structure is going to be entirely different. It's not going to be smaller units that form a larger one. Excuse me, in terms of function, right? Again, they're not going to be calorie yielding. And then they are considered micronutrients. So it is compared to our macronutrients, right? So big versus small. We really do need these vitamins in incredibly small quantities. And in fact, I'm going to try to make the case for you guys in class that there are far, far too many Americans supplementing with vitamins that do not need to be. That first page of the presentation actually links to a video with some nutritionists talking about whether or not they supplement. So you guys might want to check that out. Another concept to take away from just big overview stuff. So this term precursors or provitamins. So a nice example here is beta carotene. So you got to have beta carotene. You're going to get it from things like pumpkins and sweet potato and carrots. That beta carotene is actually a precursor or a provitamin that is needed to be able to arrive at the active form of vitamin A. So that's what that's what we're getting at with this term precursor. So a lot of key concepts coming from this slide as well as the next slide. I basically just embedded a table from your text there. So as a broad overview, we have water-soluble vitamins. That's going to be our vitamin B and C, all of our vitamin Bs and our C. And then our fat-soluble. I like this. You can remember it as a deck of cards. So vitamin D, E, K, and A are all going to be fat-soluble. And so a lot of attributes follow from that basic breakdown. So in terms of absorption, if you remember learning about absorbing fats in our GI tract, we saw that fats were unique in that when they crossed the small intestine, they didn't enter our blood, but rather they entered our lymphatic system. They went through those little lacteals. So it's the same case here with these fat-soluble vitamins. So they're going to enter our lymphatic system first when they go through our GI tract. Similarly with transport, right? With a lot of our amino acids and our carbohydrates, they can easily carry through the blood. But our fats, right? Think about cholesterol transport through the blood, and the importance I tried to place on those lipoproteins. So the LDLs, the VLDLs, the large chylomicrons, right? Those were all ways of carrying fat in the bloodstream by encapsulating it in these protein molecules so that you wouldn't have the fat separating from the plasma in our blood. So it's also the case that you oftentimes need special carriers for fat-soluble vitamins in our blood. In terms of storage, our water-soluble vitamins, if we consume them in excess, we tend to excrete those through our urinary system. Our kidneys can handle that. It's not the case with fat-soluble vitamins. We don't excrete those as readily. We do tend to store them. We're going to talk a little bit more about extreme storage of certain vitamins in the liver, that sort of thing. And so if you think about the fact that we can easily excrete excess here and we can't easily excrete excess here, then that also lends itself directly to toxicities. So if you think in your mind's eye, right, it's going to be a lot easier to get to toxic levels with the fat-soluble vitamins than it would with water-soluble vitamins. Take a look at this table. I would like you to be comfortable. I would like you to know to know the differences between water-soluble and fat-soluble in terms of those factors. And then this is really getting at that idea of toxicity. This notion of food first, I love, right? It's almost impossible to reach toxic levels of any vitamins with just foods. Those who reach toxic levels of any vitamins are doing so because they're supplementing. So this is, I'm not trying to pick on any particular brand here, so I didn't include it, but this is marketed as a daily multivitamin. We've got over 1,667% of vitamin B12, 300% of vitamin B6. Yes, those are water soluble, but why do those levels of doses? Over here, move my screen. So that's vitamin D, which is fat soluble, 250%, vitamin E, 200%, right? So it's these sorts of things where people can get themselves into trouble by over consuming. So it's definitely not the case with vitamins that more is better. That is not the case, right? More is not better if we follow this graphic here, right? That's definitely a bell-shaped curve where there's a sweet spot, right? You don't want to be too low, but you definitely don't want to be too high either. So I think that's a good stopping point just in terms of laying some basic groundwork with fat versus water-soluble vitamins. Thanks, guys. Bye.